Alright, the next section in pre-calc here, we're going to be covering section 3.6 from your book. What I'm going to start out here, it really goes over all types of asymptotes, but specifically for this video, I'm just going to talk about vertical asymptotes. So the whole goal here is to be able to find vertical asymptotes and determine the behavior of the curve near that asymptote. If you don't know what an asymptote is, those occur at, well, they're lines. It's a line that, let me write it down here for you. It's a line that the curve of a rational function approaches but never actually crosses. So let's write that down. It's a line that the curve of a rational function approaches but never actually crosses. Okay, and then we're going to talk specifically about vertical asymptotes. Those are lines. The line would be straight up and down, vertical line. So when we talk about vertical asymptotes, they occur on the graph at x values that cause your function to equal 0. I'm sorry, it's cause your function to be undefined. Okay. So vertical asymptotes, they occur on the graph at x values that cause the function to be undefined. Okay, and again, an asymptote is a line. The curve of a rational function approaches but never actually crosses. So we're going to do a couple examples here so you can kind of see and also figure out how things work here. We'll just do some simple examples. What's the most basic type of graph you would do here of a rational function? Would just be 1 over x. Okay, so you think what makes the denominator 0 would make this undefined? Well, there's going to be a vertical asymptote when x equals 0. So if I plug 0 in there, that makes this an undefined number. So there's going to be a vertical asymptote on the graph at x equals 0. And the way that would look here, I'll draw a quick XY axis there. So the vertical asymptote would be right at 0 where the y-axis is. Okay, so and we'll talk about horizontal asymptotes later, but most of us know what this looks like. Okay, so you got a curve in the first quadrant there and a curve in the third quadrant. If you look, it approaches the line x equals 0, but it'll never ever cross it. See how the curve is approaching, goes up on the left side, approaches the curve and going down. We'll talk about how we determine that behavior. Is it going up or going down here in a little bit. Some other ones. You got f of x equals 1 over x plus 2. Well, what makes the denominator go to 0 is what's going to make this undefined, and that's where your vertical asymptote is going to be. So the vertical asymptote here would occur at x equals negative 2. Okay. You might also have something a little different. You might have a polynomial So let's do x squared plus 2x plus 1. Well, we're going to have to factor that to see what makes it good as 0, to see what factors there are on the bottom there. So 1, that's x plus 1 times x plus 1, right? Now if there's two different factors here, we would have two values where there would be vertical asymptotes, but here we got x plus 1 and x plus 1. So that means that at x equals negative 1, we're going to have another vertical asymptote. Alright, here, you try one, and we'll go over it in class here. Let's do 1 over x squared plus 3x plus 2. Try that one, and we'll check it in class.